Good day, math enthusiasts! Welcome to another fun and exciting learning with us. Are you ready to have fun and be motivated to learn math? If yes, we are the Team Gold Diggers and let's make learning more fun. Let's begin. By the end of this episode, you will be able to define compound interest, determine the benefit of compound interest, differentiate simple and compound interest, discount a given amount, solve for the interest with different periodic payments, and last, solve problems involving compound interest. So basically, our discussion will be filled with interest. So does any one of you have interest in interest? Well, nowadays, very few banks pay interest based on the simple interest formula. Instead, they pay interest by using a principle called compounding. So what is it? Compound interest or compounding is defined as interest of interest. It is an essential concept to understand when managing your finances. It can help you earn a higher return on your savings and investment, but it can also work against you when you're paying interest on a loan. So to understand compound interest, let us start with recalling the concept of simple interest. You deposit money and the bank pays you interest on your deposit. So for example, if you earn 5% annual interest, a deposit of 100 pesos would gain you 5 pesos after a year. But what happens the following year? That's where compounding comes in. You will earn interest on your initial deposit and you'll earn interest on the interest you just earned. So the interest your money earns the second year will be more than the year before because your account balance is now 105 pesos and not 100 pesos. So let me elaborate. With compound interest, even if you don't make any additional deposits, your earnings will accelerate. How? Let's see. In year 1, an initial deposit of 100 pesos earns 5% interest or 5 pesos, bringing your balance to 105 pesos. In year 2, your 105 pesos earns 5% interest or 5 pesos and 25 cents, and your balance would be now 110 pesos and 25 cents. Not only did you earn 5 pesos on initial 100 pesos deposit, you also earned 25 cents on the 5 pesos in interest. While 25 cents may not sound like much at first, it adds up over time. Even if you never add another dime to that account, in 10 years you'll have more than 162 pesos thanks to the power of compound interest, and in 25 years you'll have almost 340 pesos. So the example in the screen is an example of interest compounded yearly. At many banks, including online banks, interest compounds daily and gets added to your account monthly. So the process moves even more rapidly. So do you understand, class? Okay, let's put it in another way. Think about compound interest a bit like what happens when a snowball effect occurs. A snowball starts small, but the more snow that's added, the bigger it gets. So as it grows, it becomes bigger at a faster rate. So with all these explanations, we can say that compound interest is interest earned from the original principal plus accumulated interest. Not only are you earning interest on your beginning deposit, you're earning interest on the interest. Now, how does it differ from simple interest? The difference between simple and compound interest is this. Simple interest grows slowly while compounding speeds up the process. Is it too broad? Let's be specific and let's find out which is better between the two. Simple interest is being calculated by using only the principal balance of the loan each period, while compound interest is based on the principal balance plus any outstanding interest already accrued. And simple interest has fixed percentage of principal amount borrowed, and the interest in compound interest, on the other hand, compounds over time. Simple interest has the same principal every year, while in compound interest, the amount at the end of 1 year is the principal for the next year. And lastly, simple interest is factored in business transactions, investment, and financial products extending multiple periods or years, while compounding interest can apply to open-ended situations such as credit card balance. Again, this is how simple interest and compound interest differ from each other. Now let's have this table to really show who wins when it comes to investing. Imagine that you begin with $100 like what in our example a while ago, but this time let's have a 10% annual interest. As you can see in the screen, after 50 years, your investment under simple interest has become $600 only compared to compound interest that really grows rapidly and become $11,739. So from this example, it is easy to see that if you are saving money, you would prefer compound interest. But take note that it is not the same way when you take a loan. If you are borrowing money, compounding works against you and in favor of your lender instead. You pay interest on the money you've borrowed. The following month, if you haven't paid the amount you owe in full, you will owe interest on the amount you borrowed plus the interest you've accrued. So now let's move on. Let's proceed on how are we going to calculate compound interest. So when calculating compound interest, you need to understand a few important elements or factors. Each plays its unique role in the end product, and some variables might have a significant impact on your profits. So here are the 5 main variables to consider in understanding compound interest. First, interest. This is the interest rate you earned or are charged. The higher the interest rate, the more money you earn or the more money you owe. So second is starting principal. It refers on how much money are you starting with or how big a loan did you take out. While compounding adds up over time, it's all based on the initial amount you deposit or borrow. Next, we have frequency of compounding. It is the pace at which interest is compounded. Is it daily, monthly, or annually? It determines how rapidly a balance grows. So when taking out a loan or opening a savings account, make sure you understand how often interest compounds. Next, we have duration. This refers on how long do you anticipate owning an account or paying off a loan. The longer you leave money in a savings account or the longer you hold onto a debt, the longer it has to compound and the more you'll earn or owe. And last, we have deposits and withdrawals. So, do you anticipate making a regular deposit into your account or how often will you make loan payments? Take note that the pace at which you build up your principal balance or pay down your loan makes a big difference over the long run.
Now, let's move on to the formula in compound interest. How do we able to use the compound interest formula? So, to use this formula, you will need two figures for principal amount, annual interest rate, the time factor, and also the number of compound periods. So once you have those, you can go through the process of calculating the compound interest. So here's the formula for compound interest, including the principal sum. A is equal to P multiplied by quantity 1 plus R over N raised to NT, wherein A is the future value of the investment or loan including the interest. P is the principal investment amount or the initial deposit or loan amount. Next, we have R, which is the annual interest rate that is needed to convert into decimal when it comes to solving a problem regarding the compound interest, and as the number of the times that interest is compounded per unit T, and lastly T as the time of money invested. Let me give you an example. So for example, Mrs. De La Cruz deposited 5,000 pesos into her savings account at an annual interest rate of 5%, compounded monthly. So the question is, what will be the value of her investment within 10 years? First, of course, we have to identify and list down all the given terms or values. As we notice, we have P that is equal to 5,000, interest rate with 5 or 0.05 when it converted into decimal. So N is equal to 12 and we have the time which is 10 years. Now we have to look for the future value. So we have now identified the given values. And now substitute those given values into the formula. A is equal to P multiplied by quantity 1 plus R over N raised to NT. A is equal to the value of P, which is 5,000 multiplied by quantity 1 plus 0.05, since it was the value of interest rate over 10, which is the value of time, raised to the number of times and the time of money is invested, which is equivalent to 12 multiplied by 10. So all we have to do now is to evaluate the given values using the formula. So bring down the 5,000 multiplied by quantity 1 and 0.05 over 12. That will be 0.00416 raised to 12 multiplied by 10. That is equivalent to 120. So the new equation now is A is equal to 5,000 multiplied by 1.00416 raised to 120. Next, we have to raise 1.00416 raised to 120 and multiplied by 5,000. So that will be 8,235.05. Therefore, investment balance after 10 years will be 8,235.05. That's how we get the future value. And what about the formula for interest rate when it comes to compound interest? So, here's the formula for interest rate. R is equal to N multiplied by quantity A over P raised to 1 over NT minus 1, wherein R, the interest rate, A is the future value of the investment, P is the principal investment amount, N is the number of times that is interest in compounded per unit T, and T is the time or the money is invested for. So here we go. Let me give you another example. Find the required annual interest rate to the nearest tenth of a percent. For $1,100 to grow to $1,400 if interest is compounded monthly for 7 years. Okay, this time we are going to find the interest rate in compound interest. It's also the same step with my previous example. We have to list down all the given terms and compute using the formula, but it would be different from the previous one since we are looking for the interest rate. So, the given values or terms are the following. Okay, A is equal to 1,400, P is 1,100, R is the missing value, N is equal to 12, and T is 7. Now, let's solve for it. If we plug in the given values in the formula, we will form this equation. R is equal to 12 multiplied by the quantity 1,400 over 1,100 raised to 1 over 12 times 7 minus 1. Next, bring down all the values, but 1,400 will be divided by 1,100. Okay. With that, we have R is equal to 12 multiplied by 1.27 raised to 1 divided by 84 minus 1. Next, copy the number 12 and evaluate 1.27 raised to 1 over 84 will be 1.0028 and subtracted by 1. To get the final answer, we multiplied 0.0028 to 12 so that we get 3.36% or 3.4%, which is the annual interest.
And now, let's proceed in the principle in compound interest. Example number 1. Find the present value of 8,000 due at the end of 8 years if money can be interest at 7% converted quarterly. And based on the problem, the present value is missing. And let's determine the present value that converted quarterly. When the present value are missing, the formula that we can use is P is equal to A over open parenthesis 1 plus R divided by N close parenthesis raised to N times T. P is equal to A over open parenthesis 1 plus R divided by N close parenthesis raised to N times T. And now let's substitute all the given. P is equal to 8,000 all over 1 plus 0.07 divided by 4 close parenthesis raised to 4 times 8. P is equal to 8,000 divided by open parenthesis 1 plus 0.0175 close parenthesis raised to 32, and P is equal to 8,000 all over 1.0175 raised to 32, and P is equal to 8,000 divided by 1.7422, which is the P or the present value is 4,591.89 pesos. We are done to discuss the future value, interest rate, principal, and now let's discuss the time in compound interest. The formula that we use in the time is T log open parenthesis A divide P close parenthesis all over N multiply by log open parenthesis 1 plus R divide N, which T is the time that money is invested or borrowed for. A is the value of the accrued investment or loan. P is the present value. R is the annual interest rate that converted into decimal form. N is the number of time that interest is compounded per unit. And now, let's have an example. What time is necessary for 1,000 to accumulate to 1,500 invested at 6% compounded semi-annual? And first, let's determine the given that we need in the formula, which is A is equal to 1,500, R is equal to 6% or 0.06, P is 1,000, and N is 2. And now, let's substitute the all given in the formula. T is equal to log open parenthesis 1,500 divided by 1,000 close parenthesis all over 2 times log open parenthesis 1 plus 0.06 divided by 2. T is equal to log times 1.5 all over 2 times log open parenthesis 1 plus 0.03, and T is equal to 0.4054 divided by 2 times log times 1.03, and T is equal to 0.4054 all over 2 times 0.0295, and T is equal to 0.4054 all over 0.059, and then our T is equal to 6.87. Therefore, the approximately time is 6.8 years.
Next, we have the compound interest with regular contribution. A lot of people wonder this, how to include a single formula with compound interest with monthly addition. In order to work out the calculation of it, we will use the two formula, the original formula plus the future value of series formula. This formula may assume the same as the periodic payment interval. It can be monthly compounding, monthly contributions, and many more.
If the additional deposits are made at the end of the period or end of the month, year, etc., we will use this formula. Formula of compound interest for principal, P quantity 1 plus R over N raised to N times T. And the formula for future value of the series, PMT or the monthly payment times quantity 1 plus R over N raised to N times T minus 1 over quantity R over N. Then, if the additional deposit are made to the beginning of the period or beginning of the year, etc., we will use this formula. Formula of compound interest for principal, principal multiply 1 plus r over n raised to n times t. And our formula for future value of the series is PMT, or the monthly payment, times quantity 1 plus r over n raised to n times t minus 1 over r minus n times 1 plus r over n, where a is the future value of the investment or loan including interest, and t the principal investment amount, the initial deposit or loan amount. PMT is the monthly payment, and r is the annual interest rate or decimal, n is the number of the times that interest is compounded per unit, and t is the times monthly, year, etc. the money is invested or borrowed for.
Let's have our example on compound interest with regular contribution for the end of the period. If Sammy deposited 3,000 pesos into his savings account at an annual interest of 2%, compounded monthly, with additional deposits of 80 pesos per month made at the end of each month, what is the value of his investment after 5 years? The value of the investment after 5 years can be calculated as follows. The first step we need to do is list all the given in the problem. So let's have the principal, which is 3,000 pesos. PMT, or the monthly payment of 80 pesos. The rate is 2 divided 100 is equal to 0.02, N is equal to 12, and T is equal to 5 years. After listing out all the given on our problem, let's plug it in our formula on end of the period formula. So what is the formula of the end of the period? Let's say total is equal to compound interest for principal plus the future value of a series formula. Then total is equal to P times 1 plus R divided N raised to NT plus PMT times 1 plus R over N raised to NT minus 1 divide R over N. The formula, let's plug all the given values on our formula. So, our P is 3,000 times 1 plus our R is 0.02 divide the N is 12 raised to 12 times 5 plus our PMT is equal to 80 times 1 plus 0.02 our R divide N, which is 12 raised to 12 times 5 minus 1 divide R over N, which is 0.02 divide 12. So next step is equal to 3,000 times, if we simplify the value above, we will get 1.0016 raised to 60 plus 80 multiplied by 1.0016 raised to 60 minus 1 divide 0.0016. Next, simplify the 2 on our parentheses. We will get 3,302.02 plus 80 times 0.100674619 divide 0.0016. We will get, breaking down the 3,302.02 plus, simplify all the parentheses or the equation above, we will get 5,033.73. Then add the two number. We will get 8,335.75. Therefore, the investment balance of SAMI after 5 years is 8,335.75.
So let us look for other problem. For example, your money may be compounded quarterly, but you're making contribution monthly. In this case, this formula assumes that regular deposits are paid at the beginning rather than at the end of the period. For example, an amount of $100 is deposited quarterly into a saving account at the annual interest rate of 10% compounded monthly. This value of the investment after 12 months can be calculated as follows. Let us understand first the problem. We have amount of $100 deposit quarterly in saving account. This is our PMT. With an annual interest rate of 110%, let's divide into 100 to get the decimal. So, 10 divided 100 is equals to 0.1. This is our rate or R. And our N is the value of the investment after 12 months. So, N is equals to 12. And for our principal, we have P is equals to 4 over 12 because we have quarterly and the investment after 12 months. So, 4 divided 12 is equals to 0.33333. To get the investment balance after 12 months, let's calculate it using this formula. Total is equals to PMT times P, quantity 1 plus R over N raised to quantity N times T minus 1 over R over N. Let's plug our given to our formula. So, total is equals to 100 times 0.3333 times quantity 1 plus 0.1 over 12 raised to 12 times 1. So, 1 plus 0.12 over 12, 0.1 over 12 is equals to 1.008333. And 0.1 over 12 is equals to 0.008333. So, 100 times 0.33333 times quantity 1.008333 raised to 12 minus 1 over 0.08333. And 100 times 0.3333 times 1.008333 raised to 12 minus 1 is equals to 0.104709 over 0.008333. So, 100 times 0.3333 times 0.104709 over 0.008333 is equals to 12.565583. So, 100 times 0.3333 times 12.555383 is equals to 418.85. So, the investment balance after 12 months is 418.85 US dollars.
The next topic is all about different periodic payments. When we say periodic payment, a greater number of compounding periods allows interest to be earned on or added to interest a greater number of times. And aside from that, different time periods can be allocated to the payments weekly, fortnightly, monthly, quarterly, or annual. To compute regular periodic payments of an annuity, the formula is R is equal P over 1 minus parentheses 1 plus I raised to negative n divide I. And F is equal R multiplied by 1 plus I raised to n minus 1 divide I. Where R is equal regular payments, P is equal present value, F is equal future value, I is equal interest rate per period, where I is equal I raised to m divide n. I raised to m is equal annual rate, and m is equal number of period in a year. N is number of payment, where N is equal MT, and T is equal time. Example, Paulo borrowed 100,000 pesos. He agrees to pay the principal plus interest by paying an equal amount of money each year for 3 years. What should be his annual payment if interest is 8% compounded annually? To solve the problem, first, we need to find the given. P is equal 100,000 pesos. I raised to M is equal 0.08. M is equal 1. T is equal 3 years. I is equal I raised to M divide M is equal 0.08 divide 1 is equal 0.08. N is equal MT is equal 1 times 3 is equal 3 periods. To find regular periods of payment, we use the formula R is equal P divide 1 minus parenthesis 1 plus I raised to negative N divide I. And after that, we can substitute. R is equal 100,000 divide 1 minus parenthesis 1 plus 0.08 raised to negative 3 over 0.08 equal 100,000 divide 1 minus 1.08 raised to negative 3 divide 0.08 equal 100,000 divide 1 minus 0.793,832,241 divide 0.08 equal 100,000 divide 0.206,167,759 divide 0.08 equal 100,000 divide 2,577,096,987. Therefore, the answer is 38,803.35 pesos. Example number 2. Aling Paring started to deposit 200,000 pesos quarterly and he found that pays 5.5% compounded quarterly. How much will be in the fund after 6 years? To solve the problem, first we need to find the given. R is equal 2,000 pesos. I raised to M is equal 0.055. M is equal 4. T is equal 6 years. I is equal I raised to M divide M is equal 0.055 divide 4 is equal 0.01375. N is equal MT is equal 4 times 6 is equal 24 periods. The formula that we use in the problem, F is equal R multiplied by 1 plus I raised to N minus 1 divide I. After that, we can substitute. F is equal 2,000 multiplied by 1 plus 0.01375 raised to 24 minus 1 divide 0.01375 equal 2,000 multiplied by 1.01375 raised to 24 minus 1 divide 0.01375 equal 2,000 multiplied by 1.387,844,515.1 divide 0.01375 equal 2,000 multiplied by 0.387,844,515 divide 0.01375 equal 2,000 multiplied by 28.2,068,738 equal 56,413.75 pesos. Therefore, the answer is 56,413.75 pesos.
Now let us move on to repeated percentage change. Now before we discuss this part of the lesson, let us first take a look at a question. The question states that what does a 20% sale with an additional 25% off on the $85 sweater that you have your eye on mean to you? Well, it means a big rebate. But let's see how much. If you reduce $85 by 20%, it becomes $68. Now reducing it again by 25% and it becomes $51. This is called repeated percentage change. When a number is changed by some percentage and the new number is changed by another or the same percentage. Both the percentage changes are not applied to the same original number. Now let us take some examples in solving this kind of problem. The example states that 6 months back, the cost of an air ticket from Detroit to San Francisco was $400. 4 months back, fares increased by 12.5%. Last month, the fares increased by 25%. And yesterday, the airlines again increased the fares by 11.11%. What is the price of a Detroit to San Francisco ticket today? In order to solve this problem, let us first try to identify the given in this problem. For our given, the initial price 6 months back is equal to $400, and the increase 4 months back is equal to 12.5%, or 112.5% of the original price. And the increase last month was 25%, or 125% of the original price. And the increase yesterday was 11.11%, or 111.11% of the original price. And what we are missing is the ticket price each time it increases. This shows that what we are missing are the prices of the ticket each time it increases. And since we have identified all the needed variables, we can now move on in finding our answers through our solution. In order to compute for the price of the ticket 4 months back, we're just gonna multiply 400 multiplied by 1.125, or the increase of the ticket 4 months back, which is equal to $450. And to solve for the price of the ticket last month, we're just gonna multiply the previous value of the ticket, which is $450, multiplied by 1.25, or the increase of the ticket last month. It gives us $562.5. And finally, the price of ticket today, which is equal to $562.5, or the previous value of the ticket, multiplied by 1.1111, which is equal to $625. Therefore, the price of the ticket 4 months back is equal to $450, last month is equal to $562.5, and the price of it today is equal to $625.
When there are only two successive percentage change, we can derive a formula. This formula makes the solution very simple. The formula is x plus y plus x times y over 100 is equals to z, where x is the first percentage change, and the y is the second percentage of change, and the z is the effective percentage change when a number is changed successively by 2 percentage change. Now, let's have an example. A city population was 10,000 at the end of 2008. In 2009, it increased by 20%, and in 2010, it decreased in 10%. What are the city's population at the end of 2010? In order to solve this problem, let us first identify the given in this problem, which is our x is equals to 20% and our y is equals to negative 10%. Notice the negative sign here because this is decrease. Now, let's substitute the given in the problem in the formula. Effective percentage change, which is our formula, is x plus y plus x times y over 100. Now let's substitute 20 plus negative 10 plus 20 times negative 10 over 100 is equals to 8%. Therefore, the population at the end of 2010 is equals to 10,000 times 108 over 100 is equals to 10,800.
Okay, that's the end of this episode. On behalf of our team, I hope that you learned something from us. Thank you for watching.